All right, so we are now in day 6, Advent of Code 2015, and the problem is called probably a fire hazard. So it's because your neighbors keep defeating you in the holidays housing decoration, um, house decoration contest. Year after year, you have decided to deploy 1 million light in a grid from 1000 by 1000. Nice. I think he will burn the whole neighborhood in this one. Furthermore, because you have been especially nice to this year, Santa has mailed you instruction how to display the ideal lighting configuration. Okay, nice. Light is your grid, and your grid is numbered from 0 to 999. So we have 1,000 grid, and the number from 0 to 999. And in each direction the lights at each corner from 00 and then from 099. Okay, nice. Okay, so we have instruction that turn on or turn off or toggle the lights for various of these ranges. Each decoration pairs a request oppositor, a corner or rectangle. Okay. Okay, so we have instructions similar to 00 through 22, and this one we will have like 9 lights, 3 by 3 squares. Okay, it seems straightforward. Let's see the examples. So turn on from 00 to something, turn off. Okay, so it's straightforward. I think it's a little bit some amount of coding, but the idea is clear. So we see yesterday we have some refactoring, and now it's easier to add a solution. So let's add day 6, and then we have to create also the solution and input files. So now we have the solution package day 6, and we need to have the solve function as always. Solve function with input from string, and then what we added yesterday is initializing the function. We have int function, and this function is calling the register with 2015 now in day 6, and then the function is solve. This is what we are going to do, and in the main function we just have to import it without anything, just to run the initialize. So it's really easier than having a switch case and everything. Yeah, so let's get started. So first of all, when we solve this one, we need a class, or we need a type. So we have a type. Let's name it as a point, and it is struct, and the point has two attributes or elements. It's x and y for the point, and both of them integer. And also what we have here, we have to turn on, turn off, and turn and toggle the light. So we have 3 instructions, and then we have from to. So what I am suggesting, that we have to parse the input that we have in the lines, and then after parsing it, we convert it to more or less to type. It's easier to work with. So typo, it's struct. Okay, so we can have type instruction, and it's struct, and then it has the, let's say, the action, and it's string, and it has from, so point, and then we can have to also from point. So this will be when we parse turn on, for example, turn on 0 through 999. It should be something like instruction with action is turn on, and from it's a point where x is 0 and y is 0, and you get the point. So first one, we need to start parsing. Okay, so we need the function parse line string. So let's have a line, and we need to send back the instruction. Okay, so what we will have, let's copy an example. So turn on, turn off, let's copy these ones. Okay, and it could be also, let's copy it the same, it could be toggle. So there is two ways to solve such question or such parsing. Even we can do regular expressions, or we can do normal Go strings manipulation stuff, like we search for the beginning of the string and then we parse the other part. So this is how I will proceed. So I need to initialize instruction, and the instruction action, or we can just have variable. We need instruction. Okay, so there's a command, or there is a function in strings in Go. So it can be if strings.CutPrefix. So the cut prefix is similar to has a prefix, but it's remove the first entry, which is actually what we need. So it return the coordinates, and it return also if it's found or not. So found or not. So this is codes. Let's see, or like see. Okay, so it returns the string after the cutting the prefix, and then we if it's found or not. And this is important because we cannot cut only by spaces. So we need one to turn on and one to remove the turn off, and the other one to remove the toggle. So what we can do, we can put it in an if statement, and then if found, what we need to do. So we need to assign the coordinates, which is okay, so var coordinates from string. Coordinates is correct. So what we need to do, so we need to have the coordinates, which is after removing, so it would be something like this one, which is easy parsable for everything, and also the instruction. So instruction dot action equals so what's the prefix that we need? So we need to go the line, turn off, so it's turn off, and then instruction, then coordinates equals C. So this is the first condition, and then we need something similar, else if C found strings dot cut prefix. So also what we need also now, the turn on part, and then if it's found, what we need to go, we need also instruction dot action equals turn on, sorry, and then we go coordinates equals C. So this is the second part. Else I think it's supposed to have only two, so I will not go with having like if else. So I'm just the last one. Oh no, actually we need it, so to cut this one. So else if C found strings dot cut prefix. Oh, it's cut prefix, not cut suffix. Oh, typos, my brain. The toggle. So now we found it. If we find it, we have the instruction action to toggle, and then we have the coordinates to see. So the coordinates, what we need to do with the coordinates, we need to actually now we need to parse it. So we cannot have it directly, so it's from the 0 0 to through. So okay, so now what we can use the same I think scanf that we used it 2-3 days ago. So what we can do, we can use scan format.scanf. okay, so it's correct. We need to parse the coordinates, and what we need to have a specific format. So the format that we have is actually string is something, some number, then it goes through, then another number and number. So this, it has it gives the we need to put it to instruction dot from x, which is supposed to be a pointer or a reference to it, and then we have to do the same from point. It's supposed to be instruction dot from dot y, so it looks correct. And then the second point, we have to go also instruction dot to x, and then instructions dot to dot y. Okay, so you remember the output or the return for this string is the number of successfully parsed, and then it has an error, and then we can put it in an if statement, and then we go, it's going to be a long line. Then if number not equal to 4, so if we have like wrong parsing or whatever, or the error not empty, what we can do, we can print something, printf error parsing this line, the error itself, and coordinates, and then we can have the error itself, then exit one. So we can do this and then return instruction. So first of all, we parsed the instruction, and hopefully it's correct. We parsed not the instruction, we parsed the line, and then we have the instruction. Now what we need to do, we need to parse the actual instruction. So the actual instruction, parse instruction, or like, it's not parsing actually, it's apply instruction or do instruction, the instruction from instruction, and should not provide anything, but we don't need it actually. So what we need to do, so the question, so let's go. So the question, how many lights are lit in this question? So what we need to do, we need to have the grid actually. So let's have a function, how many lights are lit, correct. So we need to have instructions actually, instructions, and its array of instruction, because the input is, let's see the input, yeah, so recording correct, not this one. So this is the input. You see it's like multiple lines. So what we need to do first, we need to instruction strings equals strings dot split. We need to split it by new line. We need to split the input by a new line. input by a new line. We need to have instructions, which is we need to make a slice of instruction, and maybe we can have the links to have instruction strings. And then what we can go for each line in okay, actually, yeah, for each line in instruction strings, range instruction strings. What we can do, instructions equals append. We need to add to the list parse line string to line instruction. Okay, no, so we need to add the instructions. We need to add the instructions to parse lines. Okay, so now it's correct. Now we have a list of instructions. Then we have to return number or integer int, and then let's just return 0. See if all this mess is working. So okay, let lights I don't know how to write light anymore. Yes, it's correct. Let lights. Okay, it's correct. How many lights are lit, and we pass the instructions. Print part 1, the lights are lit, and then lit lights. So go run year 2015, day 1. Oh, not day 1, it's day 6. Error parsing. Okay, so let's so we have an empty line, so we need to process it, and then if line is empty, continue, do nothing. Let's run it. Okay, so 0, 1 is lit, so this is what expected. We are not doing anything now, just parsing. Okay, so what we need to have, so we need to have a grid from 1000 by 1000. OBS stopped and stopped working, and the video was cut. Now it's recording again. Okay, so what I've done, I have this grid, and then I added the initialize the slice with 1000, and then since it's a grid, so it's 1000 by 1000, so each also row or each column, it's also 1000, so I have to initialize this one also. And for each instruction, I have to apply it, or I have to do some this long process. And this long process, instead of having it in the for, I just move it to a separate function. And then I started with a normal for loop where it starts from the from point, and then it end with the end point, and then the same with the y variable, so it's a rows and columns. And then I'm switching for I'm doing a switch statement for the action, so it's a turned on or turned off, or it's toggle. So I was talking about if it's toggle, what we can do in Go, or we can do like something called XOR operation. And this one, if it's 1, it will be 0. We put it will become 0, or if it's 0, it become 1, and we do it with 1. So it's like more cleaner if we do like if condition. If it's 1, then do something. If it's 0, do something. no need, we just choose XOR. So here I was returning the grid, but I was thinking that we will apply this instruction too many times, so I don't need to put the grid. So what I was thinking about, to pass the grid as a reference, so I pass it as a reference, and when I pass it as a reference, I don't need to have the return in the apply instruction function, and then I can actually have the grid to be accessed directly. And if the grid accessed directly, what will happen? Grid, okay, I don't need to return, and it's faster since it's just accessing the same memory, and then return 0. Okay, now what we need to do, we need also to count them. So now we apply all the instruction, and then now we need to count. So let's have another function, count lit lights, and then we also need a grid, but we integer, and then we return the end. So for this one, it's simply for x in range. So we can use this range 1000. So in Go, if you want to go from 0 to 9999 inclusive, we can use range to 1000. So the 1000 is exactly less than 1000. So this is equals, if we want to make for 0 x 0, then x less or equal 999. Okay, so it's the same. Then no, it's supposed to be here. Okay, so this is for the video, just keep it. Okay, and the same for y's, for y range 1000. So we need to count the lit lights. So where it's count lit lights? So what we can do, have a count zero, f grid x y 1, count plus plus, then we return count. And here what we do, we return count grid. Okay, so now we have it. So I don't want to try to run it all. So if we turn on all the lights from 00 to 9999, 9969s, we have to get 1 million. So declared in blocks. Okay, I was solving when the 0 light lights. Okay, how it is, apply instruction, this is to the grid equals 1, 10. So I don't have on, I have typo here. Okay, nice. So 1 million. If we try the other instruction from this sample, it's 1000 because it's one line or one row. Okay, nice. So let me copy the whole instructions, the whole this one. Okay, it's so 569999. Let's copy it. Nice. It's wrong. Okay, so it's correct, 569999. So now we finish the part 1. It's correct. Nice. It's easy, but so much typing. Okay, so let's read the second one. So part 2, You just finish implementing your winning light pattern when you realize that you did a mistake. Okay. Santa's message from the ancient Nordic Elvish. Okay, the lights in the grid both actually have individual brighting control. Each light you have from 0 or more. The lights are start as 0. Okay, so now instead of turning on and off, I think we have brightness level. So we need to check what is changed. So turn on is actually meaning you should increase the brightness by 1. Okay, and turn off actually decrease the brightness by 1. Nice. The toggle means increase the brightness by 2. What's the total brightness? Okay, so I think it's straightforward. We need to change in not this one. It's straightforward. What I am thinking, we need to change only the apply instruction. So we have different conditions here, so we can change this one. So I will just copy it completely as it is and name it as apply instruction 2. So he said if it's turned off, it's supposed to be -1. So let's do some check here. So if the grid x y not equal 0, then we do -1. I think we need to remove these ones here. So typos. Okay, so I think for turning off, if it's not 0, so we do -1, or we can do it, yeah, if it's more than 0, we can do 1. It's more correct condition. And for this one, we always increase by 1. And for the toggle, so it's now increased by 2, so plus 2. Okay, so now we need the total brightness. So what we need to do, we need not count the light, we need to have something very similar. Total brightness, and then instead of counting the light, we need to have some brightness, and then instead of counting, we need to have a sum, and then we need to sum plus equal, I think the sum, I'm not sure, but I think this is some brightness, sum the total brightness. Okay, and in total brightness, we just send this one back, total brightness. Okay, so part 1 is done. Let's do the part 2. Total brightness, total brightness instructions. Let's get total brightness. Instead of sum, let's say calculate total brightness. and then we have this as a total brightness. Get total brightness, and then printf part 2 is total brightness is d. It's more correct this way, and then total brightness. Okay, let's. I do so many typos. Uh-oh. Get total brightness. How it's the same? Let's try. Oh no, it's wrong. Get the total brightness. Okay. Okay, we're applying the instruction 1, so we need to apply instruction 2. Okay, it's 17 something. It was a typo, so I was in the correct screen now. Apply instruction 2, and then it was apply instruction 1, and we have now a different number. So let's try the different number again. So nice. It's too recently. We have wait for. Oh, I just submit one. What the fuck? Okay. Ten seconds. Okay, so let's wait 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, we get the star. Okay, nice. It's easy one, but so much to write. Yeah.